Yes. Here, I think you're on. There's red numbers going forward. That means
Is it recording?
There are red numbers moving forward. I think it's
Did
recording.
You press the red button?
I did.
Oh. Okay. So last week, I was fortunate enough to have been chosen by the AEWC lab at UMO to go to the Netherlands to test their offshore wind turbines that will hopefully power the state of Maine in the future. So the reason why I went to the Netherlands is because we went to a facility called Maren in the town of Wageningen. It took me a little while to learn how to say that. The only reason we went there is because it's the only place in the world that has a water basin. This is a picture with wave-making capabilities and also wind-making capabilities. If you look on the side here, there's a lot of panels. Those would oscillate and create waves, and that's what is used to test the floating wind turbines. AEWC is the lab group. They're one of the most prestigious labs in the country at this time. To be accepted into their grad program is harder than getting into MIT right now. And the Deep Sea Wind Consortium is it's a group of labs and colleges that their main goal is to make wind energy profitable for the state of Maine. It includes UMO, AEWC, and Maine Maritime. Okay, so the AEWC is the Advanced Structures and Composite Center, and they've made a lot of really good projects recently. Their main tool that they use is carbon fiber. Carbon fiber is probably the best material in the world right now because it has the best strength to weight ratio. It's incredibly light, that makes it very versatile. Their recent project is called Bridge in a Backpack. Basically, you have a hockey bag, and out of it come a bunch of inflatable arches where you can make bridges in a very quick amount of time compared to normal construction. And they're flexible when you put them up, but then when you put cement in them, they're stronger than steel. And because it's a carbon fiber exoskeleton, you see right there, the conditions that normal bridges have to undergo in Maine, like salt and snow and all that stuff, carbon fiber is totally fine with it. Maintenance is not really required for a long time, and it becomes significantly cheaper and easier than normal bridges. And that same material, carbon fiber, is used in the military to make their first ballistic panels for military tents, which significantly decreases the amount of explosion and fragmentation if they were to undergo a situation like that when they were sleeping. And right now they're doing the offshore wind project, which I'll talk about. So they were mainly testing two components of the wind turbines, the blades themselves and the platform. The blades, they were made by having an aluminum mold, two aluminum molds where they would put the carbon fiber in, and then they would put it together and put it in an oven to bake. And then they would cut off all the excess, because it's kind of liquidy and sticky when it goes in. They put on resin to make it harder before it goes in. And they're incredibly light. We felt them, and this is the 1/50th scale, where all the wind turbines that they were testing, the 1/50th of what they're actually going to be, but this one was 1/3 of a pound. And they were testing to see how well it would work, and what they actually found out is that they're going to slightly need to redesign the blade, because when you make a wind turbine, you want to look for your maximum velocity with your lift. So if you think about it like a graph, you have your lift, which is your dependent variable, and your velocity that it sees. And you get to this point up top, and then it just drops down. Think about like an airplane, where you lift its wings up, and it'll start to rise, and it'll go faster. But if you lift it up too much, it'll stall out. What they were noticing was that the wind blades, they're getting in this zone right here, so they wanted to make it a little down here so it's safer. So you're noticing when I got up to the topper speeds, with the higher speeds, it would stall out, and that's no good. Then they tested 3 different types of wind platforms. The first one that I saw was a semi-submersible, which is 3 buoys. You always want to make things in groups of 3 because it's the strongest. And then it has cables. This is the semi-submersible one. It has cables that run down and are anchored to the ground. The next one is the tension leg. which is this one that has all the weight at the bottom, some flotation, and some three metal parts going out to stabilize it. And the one that's different about this is that it's anchored straight down instead of straight across, or angled. And then the spar is this one that just goes straight down, and all the weight again is at the bottom, but it has more flotation right here. It keeps it a little bit stiffer, and the anchor is diagonal. We didn't really learn too much about the platforms themselves. I asked which one of the professors thought would work best, and they were still compiling the data. He thought all of them worked really well, and they were still figuring out what the pros and cons were. They have so much data that they need to analyze for this. They have multiple terabytes. It's going to take like 2 years to figure out what works, what doesn't work, and before they actually just figure out how to put these out here. So basically, the main goal in this is to save money and create renewable energy, because fossil fuels are running out. So right now, Maine's budget is $3.1 billion. We learned all these facts because we Skyped into a chat with Professor Dogger, who is the leader of the AEWC lab. He's really big on composites and renewable energy. He's looking towards the future and making sure that Maine is on top. So with this $3.1 billion budget, Maine pays $5 billion in fossil fuels. So we're losing quite a bit of money. And then I'm sure all of you know about gas prices. Some of you drive. It's $4 a gallon, not so fun, and you know it's rising. Also, heating oil in Maine is big. We are a cold state, and every time gas prices rise by a dollar, heating oil rises by a dollar, and Maine loses another $1 billion to fossil fuels. So we need to look for a way to expand and make something that's renewable. So right now, it takes 2.4 gigawatts to power Maine. There is so much power off of the coast of Maine. There's a potential of 150 gigawatts if we had wind farms all off the coast. If we had wind farms off the coast all the way across the United States on both sides, we could power the country 4 times over. And right now, the average family pays 15 cents a kilowatt hour. Do you guys know kilowatt hours, how that runs? Kind of? No? Okay. So imagine a highway as the power lines. A kilowatt travels from power plant where it's created, and as it runs along the line, your family pays 8 cents for it to be created and 7 cents for every hour that it goes along the track. And that builds up. And energy prices are rising quickly, as well as gas prices. It's estimated in the future, in 2020, oh wait, that's actually the next slide, my bad. The average family also pays $9,000 in gas and $1,000 in electricity, also rising. Okay. Dr. Dogger's goal is to make 5 gigawatts of power for 2030. 5 gigawatts is a lot of money to be spent, but you need to make projects that are big to begin with, because the thing that's going to cost us so much is the underwater power lines. Those are incredibly expensive. These are 50 miles off the coast. It's going to possibly take $500 million just to get one cable underwater to a farm. So you can imagine, like, if you were to put like 1 gigawatt out there, it wouldn't really, the profit wouldn't be good. He has to do it all at once to get the profit going and making the underwater cable worth it. So the estimated price of energy in 2020 is 14 to 16 cents to make. Remember, right now it's 8 cents to make and 7 cents to travel. So it would be 14, 16 cents on top of a traveling fee. Dr. Dogger believes that in 2030 he will sell the energy that's made there for 10 cents a kilowatt, which he believes will be significantly less than anything else in Maine.